Welcome to the lecture series on object oriented analysis and design. Knowing object oriented in itself is an exercise that will allow us to talk about a paradigm in a class of problems, in a class of applications that are certainly going to improve the people productivity. We have studied the idea of problem solving, how we created time. Using object oriented, we can come up to this point. That is all we need to do. After that, it becomes automatically machinizable. The way in which we have been developing tools, testing time is still intact, debugging is intact. So, we are quite confident that we can manage complexity easily in object oriented paradigm for a certain class of problems, for a certain class of applications by simply increasing the design time. So, there are 8 paradigms which are there which are very popular. They are not mutually exclusive. We have learnt lessons from the early days of computing to manage these 8 paradigms as something that can allow us to channelize our way of working in software engineering, so that in a chosen class of problems, in a chosen set of applications, we do well. The quest for a paradigm which is good for all possible applications which we are thinking about is still on. We have to acknowledge that object oriented today is quite promising, because the kind of applications that we are seeing are more like your online purchases. It is very promising in all those contexts, going online. And the beginning of all this, as I mentioned, is the need for a different thinking. It is easy to tell that we need to think differently, but the most concrete idea about what is that different thinking came from what is called classification theory, which is nicely written up in the Encyclopedia Britannica. We have Peter Code and Edward Yourdon writing up this classification theory. This is the beginning. We naturally think like that, because nature has distinguished objects. We are able to recognize the objects. We do not take so much time trying to figure out what exactly is to be done in a given environment. Even if somebody is planted in a completely different house, they can still walk around, find out, because there is some kind of familiarity, there is something which the dialogue tells that this is most probably what is to be done. So many times we keep experiencing, you go and check into the hotel for the first time, but still you are quite up and running. You can operate the room, you can operate very many things, including the television. So, we find that if we somehow manage to put this classification theory into a machinizable or automation format, then we would do better. A good class of problems are amenable, provided you answer all these questions correctly. That is difficult. If they are only tangible objects, that is what most of the times we draw attention to. Early lectures in object oriented, whatever we are talking about, are banking on tangible objects. Students relate themselves to tangible objects. The good examples that I have been talking about, trees, stones, hotel room, they are all full of tangible objects with some degree of familiarity, or since I know what I want to do, I can probably figure out how to do it with a given object. You give me a different model of a powder, I will do that, I will understand what to do. You give me a different model of a comb, I will understand what to do. Once again, the tangible object space is very limited in software engineering. We have to create these ideas in an intangible space, and that is why the difficulties are all there. What is an object? How do objects communicate? So, essentially we have to understand that so many problems are existing. Conceptually, an object is a thing you can interact with. You can send messages, it will react. How it behaves depends on the current internal state of the object. It matters which object you interact with. An object has an identity which distinguishes it from all other objects. Again, intangible space, very difficult. We can have hair splitting arguments. Therefore, please remember the very first set of lectures where we nailed out that requirements, analysis and design, all of them are full of hair splitting debates, arguments, controversies and fights. Many projects have not started at all because they can't resolve. So, what we found is we came up with a paradigm which gives us a nice language to talk about. We do not lose our experience which has been gained over several decades before 90, 3 to 4 decades of experience in building software, and after all that we have a nice language to talk about. This is how we draw a line. We talk about a design bucket, we talk about essential requirements. They are not cast in stone, they are not perfect, but then we bring into this fold of a paradigm which automatically guides us, improving our people productivity. So, what is an object? An object is a thing which has a behavior, state and an identity. This is what Grady Booch defined as in 1991, and his method, which is so nicely defined and well expressed, has found its way as one of the top 3 methods in object oriented, which we will discuss as we progress. The state of the object is all the data which it currently encapsulates. An object normally has a number of named attributes or instance variables or data members, each of which has a value. Some attributes can be mutable, an attribute address, other attributes may be constant. Essentially, we are talking about, as we progress, some attributes can be seen by everybody, some objects cannot be seen, public private attributes. Some objects you can tailor, say for example, the way in which we are talking in the online platforms. For some time I can mute my microphone, mute the video message. Invariably, even if it is a half an hour to 40-minute meeting, there will be a few statements, please mute the microphone, please unmute the video. It is happening, it is happening all along, but then we get accustomed to that. No technology is tear free, we always have to adjust, make some adjustments. It is the case of putting people and technology together, that is a challenge. In a group of applications, this paradigm is doing very well. The state is determined by the attributes, some of them are public, some of them are private, some of them we can always adjust. Date of birth, identifying numbers, behavior, the way an object acts and reacts in terms of its state changes as message passing. An object understands certain messages. The set of messages that the object understands and the set of attributes it has is normally fixed. It accepts only this many messages, it does not accept anything. So, this is how we have been talking about all along. You know, the way of object oriented behavior can also be understood, it has its own flip side, but there is a simple anecdote. In a village there was a murder. So, nobody knew how the murder happened. Obviously, the police came, there were a serious investigation happening, and they did not know how to make sure that too much of probing does not happen. So, they found one fellow who does not do much in the village, is just running around doing nothing much. So, they taught him only 3 words, yes, no, all right. So, they put this fellow, all villagers said we will help the people who are solving this problem, we will help the authorities, please catch this fellow. He is most likely to be the fellow who will give you clue for everything about the case that you are investigating. So, all people were very happy. The police officer called this fellow, asked him a simple question, did you commit the murder? Yes, that was only he taught. Do you have any excuse? No, you have to go to jail. All right, only 3. So, we build an object which is like that. In theory, yes, it is possible, we do not need the total intelligence to get this kind of an exchange. So, when we are designing the big system, we need a verification and validation. Are we meeting the requirements? Is it the problem we are solving? So, by talking about only one aspect of the paradigm, we are not doing justice to it. We are doing it because we have to study it step by step, unit by unit. Ideally, in your mind you should be able to churn out all these ideas and concepts together to understand the big picture. So, what we understood here is that the set of messages are normally fixed. Identity is a little more slippery. The idea is that objects are not defined just by the current values of their attributes. An object has continuous existence, they change, the variables change, the behavior changes. At step 1, the object was having an identity. At step 10, its identity is resembling something, some other object in the system, which is just happened. What it is doing, the value it is holding is the same. So, let us say that in the beginning we have started having students with different roll numbers, names, everything. Suddenly there is a state called first assessment. On that day, all the students of the class who are different objects with different identity are referred to similarly, completed first assessment. Based on that attribute, identity is slippery, all students have done it. Until then, yes, some students have absented, they come differently, second assessment, end semester, pass, fail. So, you please understand that in a larger system, we have some other higher order attributes and concepts that will make the identity of a particular student a little blurred. Yeah, it is true that every student has a unique roll number, every student has a track record, has a trace in the system over a span of 7 years, but then we can still talk generically about all students where the identity of a particular student is of not serious consequence in the discussion. They are also important, every student is important, but at a higher level we can talk first assessment, overall pass percentage, over 7 years employability rate. So, there are certain parameters like that. An object is normally referred to by a name, but the name of the object is not the same thing as the object. So, we talk about the identity at some point in time, it is very important, at later point in time not so important, it depends at what time you are checking the identity. A message includes a selector, here we have seen the selectors. A message may, but need not to include one or more arguments. You have to select what is the message that you are talking about, and that selection happens very carefully. Interfaces, the object's public interface defines which messages it will accept regardless of where they come from. An object can always send to itself any message. So, typically the public interfaces any part of the system can use, the larger private interface object itself and other privileged part. So, certain things are public, certain things are private, certain things we can change. The level of abstraction, the point of view is completely different. There are two people who are watching this cat. The one on the left hand side, my left hand side thinks that it is something like that, is modeled like this. The one on the right hand side thinks completely differently. It can be modeled like that. It is not right or wrong, it are two levels, there are two levels of abstraction, there are two levels of point of view. In a typical problem definition and solution, we will have to invariably assimilate multiple viewpoints. That is how we have been talking about. The next problem, classification, there is no perfect theory, the classification fails, the classification theory with which we started fails, because there are class of giraffes that are obvious, class of lions that are obvious, a class of snakes that are obvious. Now, what is this in the middle? A lion's head, giraffe body, snake tail. What is this in the middle? So, we do not have the intangible objects nicely falling in lines of tangible objects. It is easy to work with tangible objects, they speak for themselves, they tell you what to do with that, whereas intangible objects tend to be like this. It is a completely different idea, an abstract object, a head of a lion, a body of a giraffe, a tail of a snake. So, that is how it is. Each object is an instance of a class, each object knows its class. What is the reason why we are talking about classes? Because the identity is not going to hit us very hard. We can talk about certain other things which are general, because the more you generalize, the more you abstract, the better you manage complexity. There is no second opinion about it. Abstraction remains the number one idea in computer science. Abstraction remains the number one idea in science, which is allowing us to solve more and more complex problems. The language of expression may be different, but abstraction is essential, and India takes pride in producing people who are that abstracting and they are that brilliant. Each object is an instance of a class, each object knows its class, each instance has its own value for each attribute, but shares the attribute names and operations with other instances of the class. Class encapsulates data and behavior, hiding implementation details of an object. These are the relationships. Association, like we have seen in the earlier lectures, if the associations are nicely forming based on one to one, many to many, or any other known relationship, sets and relationship and function mapping, we are doing very well. Aggregation, if you can very quickly find out which classes will give you a component. Generalization for inheritance and further building on the complexity. Why do we have classes? Why not just have objects which have a state behavior? Classes in object oriented language serve two purposes. Convenient way of describing a collection of objects which have the same properties. In most modern OO languages, classes are used in the same way that types are used in many other languages. So, the essence of object oriented is the more generic we become, the more generalized we talk, the higher will be the degree of complexity we can handle, and the higher we progress from what we are to completion without redoing much. We do not scrap anything. Progressively we move towards building more and more things. Often people think of classes and types as being the same thing. Indeed, it is convenient and not often misleading, but it is not the same. They are not the types. It is not merely the data, it also has the method. Type always talks about data. The idea of type was most welcome. We talked about strongly typed languages where the end result of an expression, the type of the result of the expression is known at the compile time. The right hand side and the left hand side are so well known that the RHS of the expression should give the type of the LHS. Typing of variables, what type of variables, has been a great lesson which we learnt very early in the programming. All variables are not the same, they cannot be handled similarly, they do not lead to the same abstraction. All data is not the same because the spelling DA holds good for all data. Some are integers, some are Boolean, some are real numbers. All these things make a notion of a difference. We learnt it in mathematics. Some are natural numbers, some are integers, some are with negative numbers. The idea of negative number itself was a great idea, because we only started counting numbers. What is a negative number? Remember that a class defines not only what messages an object understands, it also defines what the object does in response to the messages. So, it is not only the data, it is also a behavior. State plus behavior, that defines the object. Data is a part of an object, so are the operations that are performing on the object. So, what we did is, in the earlier days the data and the operations were thought of differently. Now, we are asking that question, which subset of the well defined input data goes with what operations, put them together, call it an object. If you can identify such classes and objects, you can easily piece together your solution. As you analyze and design, we can also see the solution emerging very quickly. Very quickly, all stakeholders, the developers, the customers will come to a conclusion that yes, we are progressing, we will have high productivity, and then we can have a tool that can generate the code, that can generate so many things. Polymorphism, it means that the same operation may behave differently on objects of different underlying class. This is a multiplier. How does it matter whether it is multiplying integers, real numbers? Depending on the data, it will act. The calculator has only one symbol for multiplication. It can take care of decimal numbers, it can take care of integers, it can take care of negative numbers. Whatever you are talking about, only one symbol. Multiplier, one button multiplier is there. Object oriented programming language automatically selects the correct method to implement an operation based on the name of the object. Imagine how much space you would have lost if you wanted a green button for multiplying integers, a blue button for multiplying real numbers, a red button for multiplying negative numbers. 3 buttons are wasted on that space. Instead, you write the piece of software that automatically recognizes whether they are integers, real numbers or negative numbers, the same button multiplier will solve the problem. So, once again we must understand that between hardware and software we are not likely to decide very soon. Whatever you can do in software you can do in hardware and vice versa. Hardware is inflexible, software is flexible. That is the reason why we started investing in software, because we need not freeze everything in flesh and blood immediately like the hardware demands. It can happen later. The hardware has matured, we have discussed all these things earlier. So, it can be determined. However, hardware is inexpensive only if multiple pieces of that hardware are necessary. If only one chip is to be made, it will cost 10 lakhs. If 10 lakhs chips are necessary, it will cost only 50 rupees, because the design is the same, the fabrication is the same. Whereas, in the case of software, the economics are completely different. We think that once the piece of software is made, it can be used any number of times. We will not go into the serious economics of that, but then the fact is, first time it will cost, after that what is the cost? There is nothing, not even material is there, the same machine is there, next one it should be free. So, polymorphism was a good idea in that sense that we have spoken about a similar looking function becoming a bit more sensitive to what are the attributes coming and acting accordingly. It is a good example. Start engine, it is the same, start ignition is the same, whether it is my scooter or the car or a boat, the ignition key is necessary, the operation is the same, but the way it behaves is completely different. The scooter key cannot go into the car key. There is a point in time when we were working, again people who work in the open field, open source model have tried certain problems like that, like we had single password, one login, all these things were spoken of, exactly one login. Now, what is happening is that if you forget the login ID or the login is broken, everything is broken. Like that, can we have a key for my house, for my office room, for my car and the scooter, same key, same ignition key? In theory, yes, it is a good problem. For some time we tried. These are open problems. What is the problem? What is wrong with this? One is, if you lose that single logon process, if that is broken, very vulnerable, everything will be broken. If you lose that one master key, nothing can be used. So, it all depends on the mission criticality, the context. In theory, everything is possible, but these ideas did not take off. Now, I have one key for my scooter, one key for my car, one key for my house, one key for my office and one more key for the office almirah. So, I have a bunch of keys and I find it very cumbersome, not because it is a difficult exercise, but it is a boring exercise, not at all difficult. And therefore, what is it that we are talking about? The sharing of attributes and operations among classes based upon a hierarchical relationship. Is it possible to tell that once the key is found, the method to open the particular lock is the same? So, we define a class called locks. In the initial days, they were all called ignition locks. We were not referring to the key, we were talking to the lock, ignition lock, car ignition lock, scooter ignition lock, house lock, office lock. So, all that you have to do is, once the key is determined, selected, the entire operation is the same. A class of locks are available which have different keys, but once the key is chosen, once the key message is sent, automatically it will open the corresponding lock. Can be defined broadly and then refined into successively finer subclasses. Subclass, superclass, a class can have a subclass, a class can have a superclass. For the superclass, you get something in, it can hide a few things, pass on to the subclass, it can happen. So, object inheritance can be a single inheritance or a multiple inheritance. So, we talked about multiple inheritance when a single object draws from two amphibious vehicle, land vehicle, water vehicle, boat and car. Land vehicle is exclusively car, amphibious vehicle, it can be on the land, it can be on the water, it can be a boat. So, now what is happening? This particular vehicle called amphibious vehicle is drawing from land vehicle and water vehicle. Some properties of land vehicle, some properties of water vehicle. It is unlike boat, it is unlike car. This is a midway, it runs on both. Classification inheritance, the base class captures the common information and features of the derived classes. The base class is giving you what are all common, either attributes or operations, either you add or subtract in the derived classes. Can be a subclass, from subclass you can go to superclass. Customization, how do we do this exercise? An existing class is used to create a customized version of the class or a common design interface. A base class may define the design requirements for its derived classes by specifying a set of member functions that are required to be provided by each of its derived classes. Sharing is also a basic idea of inheritance, the ability of one class to share the behavior of another class, not completely redefined, not completely reclassified, but I can pluck some methods, share them, it can be defined. It all depends on the richness of the programming language to support these features. The idea of talking about knowing OO in this level of abstraction is we are language independent. Not all languages support all these features. C++ supports some, Java supports some, Ada support. Tomorrow we may get a language where sharing is the most common thing. In C++ it becomes difficult outside of a friend function. C++ had its own language, it has its own language. There is a friend function, it can share. An approach which allows classes to be created based on an old class. You can have a friend function, static or dynamic, implicit or explicit, per object or per group. We can define lot of semantics. There are so many advantages of working at this level. The solution is so robust, the solution is so flexible, the solution matches the way we are thinking about the problem, not about the technology. The solution is matching the way we are thinking about the problem. All this is correct, multiple combinations are possible, but then the language should support. How many of these features a given language is supporting? Not all. Object oriented paradigm is a bigger exercise. A language of choice is subscribing to that paradigm in a manner where the context free grammar is elegant, efficient and consistent. A compiler can be written automatically, the executable works on the machine. Therefore, language is and the language concepts have to decide the consistency, the coherence and the completeness of that language is more important. By far C++ and Java score well. The maximum truthfulness with which the ideas in object oriented paradigm are translated. And the problem is like this, we are true to the problem. Subclassing means not only inheritance of specification, but also inheritance of implementation, and so can be viewed as usability mechanism. Well, we talk about usability, we talk about reusability. We are very clear in our mind that unless you show reusability, we do not get the cost effectiveness in object oriented. So, we have to use the code, you have to reuse the code. So, we have to have a way of telling that some components are generic, we should be able to bring them back, do not start from the scratch, buy some. So, as you are doing the top down analysis, if you recognize that some of the components you have already done, they are prefabricated, please use them, reuse them. In verticals like space applications, reusability is maximizable. However, in other applications some functionality is common, but not the entire one. Most of the services that we are talking about use roughly the same. Yesterday I was talking about form filling. So many forms we are filling. For every webinar we have to register, for every registration we have a form. We took a good example of form filling, checking the form. Important aspects, what is the degree of modifiability of a subclass? How much can you change? If it is completely different than the base class, why do you want to call it a subclass? I have 10 things in the base class, but I am blocking 9 of them, I use only one, then maybe you think of a better base class. So, to summarize, we are talking about attributes, no redefinition, ideally it is like that, arbitrary redefinition, redefinition without constraints, constraint redefinition, hidden redefinition. So, therefore, the object oriented paradigm tells us that this much flexibility you have, this much restrictions we have, and in doing so we are focused on the problem and its solution, and not the language and the machine on which it is going to be working on. So, that is the shift which object oriented paradigm has given, and we are addressing a very good complexity of problems, reasonable number of problems. However, the number one hard problem is object identification and modeling. If we have to reinvent the wheel each time, we are not likely to show a good success rate. If we take recourse to methods, then yes. So, we have certain nice ideas already specified in the paradigm for attributes, for operations, constraint redefinition. Therefore, we have a way of solving any conflicts in the in between, because we have well laid rules and procedures. The object oriented paradigm tells us this can be done, this cannot be done, and we are not losing out on our earlier programming experience. We are not doing anything outside of the requirement on increasing the design phase, reducing the coding phase, retaining the analysis phase and testing as they are.